Welcome to GIS 311 Summer 2020. This is a lecture for Day 5, which is Lab 3 preparatory material. Lab 3 can be completed in just a few hours. However, students have until 19 July 2020, which is a Monday evening, because Lab 2 technically began on 7 July 2020. This lecture is technically should be viewed prior to 9 July 2020, but it's okay if you have not. As the course progresses, labs will consist of new material being presented based on the foundation of skills that you completed in previous labs. The old material will be presented with little guidance in how to specifically accomplish them. Use the resources presented in earlier labs, your notes, and the technical videos resources. The goal is for you to build on your skills with decreasing reliance on previous labs for successful completion. Calendar overview. This is week 3, and this is the lecture for 9 July 2020. There's a previous lecture for 7 July 2020, and again, this is day 5. As a reminder, there is no Zoom or class on 14 and 16 July. I'll be attending an Esri virtual conference. You may wish to attend. It's not required, but you may want to Google Esri virtual user conference and register for the courses and the sessions. This lecture is intended to replace the traditional lecture that would have been presented on 9 July 2020. Hopefully you are watching it prior to this date so that you are prepared for Lab 3. This should be viewed first in priority in terms of preparing for Lab 3. There are Lab 3 playlists and suggested reading items to help you prepare for the Lab 2 preparatory quizzes. There are 2. Agenda for this lecture. Prior to this lecture, it would be ideal if you have already completed Lab 2, but it is not required. I'll be covering 2 maps of the day, which are 2 different slides. I'll be mentioning the videos that you should watch in preparation for Lab 3. I'll be going over some specific vocabulary. And as a reminder, this is a mini lecture video. It's going to be about 30 minutes long, as well as the readings and other videos to help you complete online Quiz 7, Lab 3 preparation. In addition, you should watch the Lab 3 technical videos, which are known as Quiz 3 with a K, and complete the online demo quiz, which is Online Quiz 8. Quizzes with a K came about when the quizzes were done in class, and it was a karaoke style presentation. The students would follow the bouncing ball and complete a quiz in class. It is now changed up so that you will watch me in the demo videos, technical demo videos, completing the quizzes. You, though, will need only make sure you have the correct answers to the questions for each numbered question item, so that when you take the online quiz in Canvas, specifically number 8, you will have all of the answers ready to take the quiz. This is one of my favorite maps of the day. It is by a daughter of Janelle K., a student in the GIS certificate program in 2017. Janelle has also completed our Master of Science in Geospatial Technologies. When taking GIS 312, Janelle's daughter was trying to figure out what mom was learning in school, and she determined that maps have squiggly lines and roads. There's a map drawn by the daughter, and at that time there was a required cartographic critique, and Janelle said that she would have added a reference map and a possible legend. So obviously just making a small joke, but this was one of my favorites, that a daughter of a student was interested in what mom was learning. This next map of the day is a map completed by a young woman named Masha P., 12 years old, while on a flight from Seattle to Frankfurt in 2018. This was completed, I believe, on a Galaxy S7. So we have a 10-hour flight, and supposedly Greenland. And notice that it's white, but green is in the label. There's another 3-hour flight to Moscow, 5-hour stop indicated in Frankfurt, and then there's a note of being home when she arrived in Moscow. So I thought this was interesting as well. Videos and other information. There are 3 required videos in the module for the lecture portion of the quiz. There are also a series of quiz 3 video lecture steps, going from steps 1 and 2 is one video. There's a step 3, which is one video. Steps 4 and 5 is a third video, and then step 6 is a fourth video. Those are for the demo quiz. If you have any questions, please feel free to ask. These 3 videos, the globe being cut open, West Wing, and maps that prove you don't really know the Earth, are preparatory for the lecture quiz. Again, online quiz 7 is based on this video, the readings, and the 3 videos listed here: the globe, West Wing, and maps that prove you don't really know Earth. The online quiz 8 is based on 4 quiz 3 video demos. There's one that's steps 1 and 2 from the directions, there's one that's steps 3, there's one that's steps 4 and 5, and there's a fourth, step 6. This slide has several terms of vocabulary that will help you in the online quizzes. Geodesy is the science of accurately measuring and understanding 3 fundamental properties of the Earth: its geometric shape, its orientation in space, and its gravity field, as well as the changes of these properties with time. Ellipsoid or spheroid is a spheroidal volume with unequal axes, used to approximate the shape of the Earth in map projections. A datum is a combination of an Earth ellipsoid and a reference point to reduce mapping discrepancies for a particular region. A geodetic datum is an abstract coordinate system with a reference surface, such as sea level, that serves to provide known location to begin surveys and create maps. In this way, datums act similar to starting points when you give someone directions. For instance, when you want to tell someone how to get to your house, you give them a starting point that they know, like a crossroads or a building address. Geodesists and surveyors use datums to create a starting or reference point for floodplain maps, property boundaries, construction surveys, levee design, or other work requiring accurate coordinates that are consistent with one another. There are 2 main datums in the United States. Horizontal datums measure positions, latitude and longitude on the surface of the Earth, while vertical datums are used to measure land elevations and water depths. Geoid, or geoid, the shape of the Earth as defined by mean sea level and affected by topographical and gravitational factors. Graticule, marks of latitude and longitude forming a grid on the globe, as found in Geographic Coordinate Systems, or GCS. A projection is a map mathematical transformation that converts spherical units of latitude and longitude to a planar x and y coordinate system, or a flat map. This slide gives an example of length differences between the equator and 40 degrees north. They are both at 50 degrees east, but the length at the equator is longer. As an example, where my mouse is at a 0, 0, going 50 degrees east, this length right here in purple would be much longer than, for example, at 40 degrees north. Even though it is 50 degrees east, once we go 40 degrees north, the distance is much smaller because it's moving closer to the North Pole, and thus these lines of latitude, as it passes from 0 to 50 degrees east, is much shorter up here at 40 degrees north versus down at the equator. A coordinate system is a geographic coordinate system is a method for describing the position of a geographic location on the Earth's surface using spherical measures of latitude and longitude. This is a method for identifying the location of the point on the Earth using coordinates, x and y, for example. A projection is a mathematical transformation that converts spherical units of latitude and longitude to a planar x and y coordinate system, or a flat map. And therein lies the problem of getting from a round or a spheroid to a flat map. A projected coordinate system is defined on a flat two-dimensional surface. Unlike a geographic coordinate system, a projected coordinate system has constant lengths, angles, and areas across the two dimensions. A projected coordinate system is always based on a specific geographic coordinate system that is based on a sphere or a spheroid. In terms of latitude and longitude, or longitude and latitude, the longitude value is usually listed first, then the latitude. This corresponds to the XY pairs in a Cartesian coordinate system. On the globe, the x-axis could be the equator. However, the numerical values come from the lines of longitude. So notice this equator, these values are actually lines coming from the longitude. The y-axis could be the prime meridian, which runs north to south. However, the numerical values come from the lines of latitude, such as these. Negative values represent locations in the western hemisphere, while negative y values indicate locations in the southern hemisphere. Locational information does not have to be latitude or longitude. It could be street addresses or anything else that can be geocoded or mapped based on some sort of specific location. There are two major types of coordinate systems, geographic and projected. Projected coordinate systems are flat, whereas geographic coordinate systems are spherical. When we convert from real life, geographic, to projected, our flat maps, values become inaccurate. As noted in the Esri desktop help images, if we have an area on the globe as represented by this arc and flatten it to a projected plane, this distance up here at the top of the arc where my mouse is moving must be adjusted to meet the flat projected plane, and that's where things get skewed. This much of the Earth's surface has to fit onto this much map surface. Much of the Earth's surface has to be represented smaller than the normal scale. The image on the right depicts a see-through globe with lines of longitude and latitude, and a light bulb placed within this see-through globe. A cylinder is placed completely around the globe, and when the light shines through the see-through globe, lines are projected onto the piece of paper. The piece of paper is then rolled out, and these lines depict the lines of latitude and the lines of longitude. And notice how they are no longer equally spaced. And this is where the distortions come in. There are multiple types of projections. The link to document gives additional information. For our use, I'm just going to mention 5 different types of projections. There's conic tangent and conic secant, cylindrical, and polar. This image on the right is a mock-up of a fly and a projection, and it's my image to represent projection on the fly. This is an Esri term, projection on the fly, and it is something that ArcMap does automatically. It is not something though that we want to use, which is why we always clear the projection as we add data to our map. We always want to use the actual coordinate system and projection. ArcMap will try to convert our data into a certain projection, usually the projection of the latest piece of data that was added to the map. But in order to make sure that our layers and therefore our data line up, we must clear the projection anytime we add data to the map and avoid projecting on the fly. So how do we get our data to line up properly? We have to use the proper tool for the job. Define projection only changes the label of the coordinate system and projection within the data. It does not change the coordinates, and it does not create a new data set. The project tool creates a new data set in a different coordinate system and projection. It changes the definition and it creates a new data set. There is a rule that you will have to memorize for working with data. If a piece of data or a layer has some sort of spatial reference, the answer is easy. You simply project. That's all you have to do. If a piece of data does not have any spatial reference, therefore it is unknown or undefined, you will have to define the projection, use the define projection tool, and then project. And in addition to this, the define projection tool in this class is only run with one specific value, and we'll get to that in the demo videos. This image by Peter H. Dana from the 23rd of June 1997. He placed 3 map projections centered at 39 degrees north, 96 degrees west. Using Mercator, outlined in red, Lambert conformal conic in blue, and an unprojected latitude and longitude, this map can depict how off our data would be if we were to continue to use data from these three dissimilar coordinate systems. Notice that the Puget Sound is way up here in the Lambert conformal conic. It is right about here in the Mercator, and in the unprojected latitude and longitude or geographic coordinate system, the tip of the Puget Sound, Olympia, for example, is down here. So our data would be off by 100 miles and several hundred miles if we were to not line up our data. And this is, again, is just a depiction where the map projections are centered at 39 degrees north and 96 degrees west for this example, being this image, this location right here. If we were to use UTM or Universal Transverse Mercator System, we would use UTM Zone 10N for Pierce County, Washington. UTM Zone 10 is right here, and we are north of the equator, so we would be UTM Zone 10 and N for north. And we will use this coordinate system for some of our labs. As we wrap up this video, as just a reminder, if you're interested in following along with the quiz, again with a K because it used to be like a karaoke experiment, and this is not required, this is what your directory would look like. The directions and the data are in Canvas. Again, this is not required, that is, to follow along. However, you will need the answers to the questions with the proper question numbers for when you complete online quiz 8. And there are 4 separate videos for the quiz 3 demo lecture, the technical skills videos. The additional quiz 3 videos, again there are 4. One has steps 1 and 2 from the directions, one is step 3 from the directions, another has steps 4 and 5 from the directions, and then the fourth has step 6 from the directions. They are long because the quiz is long, but you do not need to complete the exercise. You need only watch, pay attention, and take notes to help you prepare for Lab 3. It's a very detailed video and has a plethora of new information and questions that you must be prepared to answer in the quiz. You can navigate to Canvas to watch this video, which is the lecture video, and also the demo quiz videos. And again, those are for the demos. Answer the questions in preparation for the lab quiz or Lab 3 lecture video quiz. Thus, you're taking online quiz 7 and 8, which are both an introduction to Lab 3. Required assignments reminder. It is highly suggested that you get started on the midterm as soon as possible. In summer 2020, there are no class sessions during the following week, so you may want to take that time to complete your midterm and perhaps the final. Read, skim, save, and bookmark the Lab 3 required reading and resources links provided to prepare you for both of the quizzes. Watch this video, of course. Watch, take notes, and answer questions in the video demonstrations. Take online quiz 7, Intro to Lab 3, from numbers 2 and 3 above, and then take the online quiz 8 using your answers from number 4 above, which are the 4 specific demonstration videos. There are other assignments due, and you should verify them in Canvas so that you know what is due and when. This is not a complete list. This is just a reminder. This is the end of day 5 lecture. Feel free to email me if you have questions. While this course is self-paced for the most part, and with minimal deductions for late work, I highly suggest you do not wait until the end of the quarter to complete your work. For reference, this course could be completed in 4 weeks. This is the first year that is run for the entire term, full term, A and B. In the past 4 or 5 years, students have completed all of this work with much success in just 4 weeks. The class met 2 times a week for 5 or 6 hours a day. Thus, it can be done. And if you haven't submitted anything yet, you can still end up with a 4.0 in this class. The most important thing is to get the work done, to complete the tasks that are put in front of you using the specific directions provided. Please reach out. Keep the lines of communication open. I am happy to work with you and help you get through this material. I hope you, your family, and friends are healthy, staying healthy in this COVID-19 era, and I look forward to seeing you on the Zoom sessions.